Hi viewers, welcome to another video of Smart Pathshala. So this video will contain two sections. One is the elementary operations of matrix, another is the multiplication of matrix as promised earlier. I know this is reverse, but actually the preference of elementary operations is more as asked by our viewers, right? Okay, now let's start. Say the elementary operation are of actually 6 types. One is the row can be interchanged and the column can be interchanged. Whatever you can do in rows, you can also apply in the column as well. Now the thing is that I didn't tell you what is Ri, right? So Ri is actually, I means stand for 1 2 3 4 5 6. Now Ri means obviously R1 means you have the first row, R2 means you have the second row. Now one thing is important, when you are applying Ri elementary operation, then Ri must be included in the operation. Like you are multiplying Ri with k, where k is some scalar quantity. Similarly, you are doing it for the column. Okay. Now on the fifth property, we have Ri is equal to Ri plus R2 or Rj. That means you can apply operations between two rows of the same matrix or two columns of the same matrix, like Ri plus Rj, or you can have Ci change to Ci plus k into Cj, which means you are multiplying k, a scalar term, to a row Cj, right? Okay, now these 6 are actually the elementary operations. Now let's see an example of 2 by 2 matrix where A is given by 2 5 1 3. Now we will apply these elementary operations to find the inverse of the matrix. Now remember this type of the algorithm, obviously you should note down the algorithm in which we are going to find the inverse of this matrix in this video, because this is very important and it comes in many examples, right? So we know we can write some matrix like in this form, A is equal to I into A. This has been written in the previous lecture. Okay, now inverse. Okay, now how can I find the inverse? Actually there are some properties. The properties is that we can find the inverse of a matrix by using matrix method when this is square, and one thing is that the inverse of a matrix is unique, right? Remember these things. Okay, now let's move. Okay, now here we will apply a elementary operation which is R1 changed to R1 minus R2. Okay, now so 2 minus 1. Now the main motive is to convert this matrix into I as written over with an arrow sign. Okay, now we do this operation and we get 1 minus 1 0 1 A. Fine. Now we have to remember, we have to convert this Lhs matrix into identity matrix. So the R1 and C1 element is 1. We need to convert the other element into 0. So we are applying R2 change to R2 is equal to R2 minus R1. Right. Similarly, we will apply the different stuffs over there. Okay. So 1 minus 1, which means 2 and A. Okay. Now let's go to another line. Now see, the most important thing is when you are applying the row operation, you should maintain the row operation, and if you are applying column operation, you should maintain the column operation. Okay, now this cannot be done that if you are applying row operation in one of the line, and then on the next line you are applying column operation. Okay, now in this step we are applying this operation R1 change to R1 minus 2 R2, right? Go to the fifth property, you can find that. So we have 1 plus 2, and here minus 1 minus 2 into 2, so and that will be into A. So what you are having is 1 0 as well, 0 1, hence we are getting the identity matrix. And here is 3 minus 5 minus 1 2, and you are having A. Now we are having this term as I is equal to some blank matrix into A. So we can write that from definition of inverse of a matrix, we have A inverse as 3 minus 5 minus 1 and 2. Now we will apply the similar matrix in 3 by 3 form. Normally you will see in exam 3 by 3 form. Those types of problems are given in the exam hall for 6 marks or 5 marks, and if it's only 2 by 2 matrix, and it will be obviously of minimum marks. Okay, now let's see a problem. I again repeat that one of the most important step to maintain is that when you are applying row operation, you should stick to row operation. When you are applying column operation, you should stick to column operation only. Remember this thing. Now, let me write this thing so that you can note it down, because this is very important step. Otherwise, you will get an answer, but that answer will not be unique, or that answer will be false, will result into false answer. Sorry. Okay. And if you are applying row operation, then you should stick to row operation for the further steps. Okay. Also, I forgot to mention that on the next section of this lecture, you should be having some problems regarding matrix multiplication. So here, let us see a problem of 3 by 3 matrix, or how to find the inverse of a matrix using elementary operation of a 3 by 3 matrix. Let's say we are having a matrix A is equal to minus 1, 1, 2, 1, 2, 3, and 3, 1, 1. Okay. Then we will write A is equal to I into A, right? Okay, fine. Now, the aim is to convert the left hand side matrix into inverse matrix by applying elementary operations simultaneously in A and identity matrix of the right hand side matrix. If I am speaking too much faster, then obviously you should pause the video, or you should run the video in 0.75x. Okay. Now, what we should apply is the elementary operation, right? Fine. So, yeah, so this matrix is equal to this into A. So, what operation will apply? Obviously, we'll apply R1 minus R2. Okay. Okay. Sorry, R1 interchange to R2. Okay. Now, this step is, I have done this step because on the 1, 1 position of any matrix, of identity matrix, there is obviously 1, and I can see 1, 1 in the R2 first column position. That's why I have interchanges, so that we can achieve the first element correctly, right? So this is the first step to achieve the first element correctly. Okay, fine. Perfect. And let us apply another step. So here is a minus 1 we can see, so we need to make it 0, right? And here is a 3 you can see, we need to make it 0 again. Okay, now let's apply some elementary operation. One is R2 change to R2 plus R1, fine. Okay, and R3 change to R3 minus 3 into R1. Okay, now that will convert this encircled 2 element into 0. Okay, fine. Now look the algorithm, look at the position in which I am converting the elements as 0. Okay, you should apply the same algorithm in the elementary operation, and that elementary operation will be jalabat toralong, we say in Bengali, which means as easy as water. Okay, so we are having 0, 0, and yep, 2, 3, 2, 5, and 1 minus 6, and 1 minus 9, and similarly you should apply the same over here. R1 no change, R2 has change, where R1 plus R2. Yeah, so 0, and you have here minus 3, correct, and then 1, fine. Okay, now let's move to another step. We need to apply more elements into 0 and 1, right? Okay, fine. Now, without having any change of in the, now let us write after simplifying. Okay, 1, 1, 0, 0 minus 3, and 1. Okay, let us write in A. Now the next step. Okay, here we need to convert more elements into 0. Okay, now notice this 3, 5, 5, 8, we don't have any common factor, so no number is a common factor of is a multiple of another, so that we can multiply with some other quantities and we will form it. No. Now what we need to do actually is that we need to multiply some quantity to R2 or R3, and then we should add it to R2 or R3 so that we can get our desired element. Okay, now this is a tricky part. What element you should apply? Fine. Okay, so let's see what element we should apply. We should change R2, because R2 in the encircled position we should make it 1. Now remember, if you are applying R2 plus 1 by 5th of R3, what you are getting, okay? Or you can say you have 2 by 5th of R3, what you are getting is 3 minus 2, which is 1. Obviously that's the desired position. Remember, we have replaced this first C1. While applying the row operation, we are converting the column wise. First column 1 and then column 2, then column 3. We are applying like this, okay? So R2 plus 2 by 5 into R3. So 2 by 5 means 5 goes 1 and 8 by 5. Yeah, so we have 5 minus 8 by 5. So we have, yeah, fine. And we have minus 8. Perfect. Okay. Now the same thing will be applied in I matrix also. Okay. So as it is 0, so there will be no change, but here it will be changed because this is R1 minus 2 by 5, which means 1 minus 6 by 5. So it means 5 minus 6 by 5. Okay. Sorry for that. 1 minus 3 into we are having 2 by 5. So what it remains as it with minus 1 by 5. Perfect. Okay, now 0. 0 obviously 0 plus 2 by 5, right? So we have 2 by 5. And R3 has no change at all. Fine. Okay. Now let's move to another step. Now here we need to convert this 2. Okay. Now please, I urge every one of you to remember my steps. Okay. First, convert 1 of each column and then convert 0 of each column, right? If you are applying row operation, while if you are applying column operation, then first convert 1 of your row and then convert 0 of your row. And here R1 change to R1 minus 2R2. And similarly R3 change to R3 plus 5R2. So what we have here, R1 change to minus 2R2. So we have here 0. So we have 18 by 5, and here R2 is will be having no change at all, and R3 we have R3 plus 5 by 2, and here we are having fine. So you have 9 and you have minus 2 here when R2 change, and you have 1 and you have minus 4 by 5 A. Okay. Similarly R2 will be having no change in this case, 2 by 5 and A, and R3 will be changed. Okay, so 0 plus 5 into this R2. Okay, so we are having 5, and here is it's clearly minus 4, and then here is 3. On the next line, let us write this simplified form: 0, 1, 9 by 5, 0, 0 and 1. Fine. Now see, only 2 terms will have to be converted into 0. Okay, now let's convert these 2 terms. These things are very easy. Only thing is that you need to focus. Now we need to convert this 2 terms into 0. Now remember, these 2 terms are in column 3. Okay, now we need to apply whatever we need to multiply is that with the 1 of column 3. Now the 1 of column 3 is that position of R3, which means the third row. So we need to multiply some number with R3, and that simplify apply operation with the R3 to get our desired value, which means we are getting R1 change to R1 plus 3 by 5 into R3, and similarly R2 change to R2. Obviously it will be minus, and 9 by 5 into R3. Fine. Now apply this thing, then you are getting the I matrix, and hence you will obtain the required inverse. Perfect. Okay. So we write 1, 0, and here is obviously 1 is there, so we are having 0. Similarly, 0, and here is 1 because 0 was there over. And obviously we have applied this formula to have an identity matrix, and we are getting the identity matrix, right? Okay. Now don't get excited at this, because this is most typical part of this problem, because you need to simplify here. So silly mistakes have been done in this step. Okay. Now R1. So R1 is minus 2 plus 5 by 3. Sorry, 3 by 5, which means we are left with 1. And similarly, we are left with okay, here is 7 by 5 minus 12 by 5. Perfect. Perfect. Okay. And here is, we have minus 4 by 5 plus 9 by 5, which means you have 1, 5 by 5. Perfect. Right. Let's rub it. Okay. Sorry for your delay a little bit. Okay. Now let's move to R2. R2 says, R2 changes to R2 minus 9 by 5 into R3. So similarly, if you apply this thing, what you will be having is minus 8, and here you will have a minus 1 by 5 plus 36 by 5. Okay? Yeah, 36 by 5. So remember, we have minus 1 plus 36. So actually you are having 35 by 5, which means you are having 7. Okay, let's write this down. 5. Sorry again. Okay, so now here we have 2 by 5 and minus 27 by 5. Okay, and R3 don't have any change, so write it down in a simplified form. Here you have minus 1, here 1, and here you have minus 8, and here you have 7, and here you have minus 25, so you have minus 5, 5, minus 4, 3, and A. Now again, according to the definition of matrix inverse, we are having the A inverse as this matrix. Fine. Hence, A inverse is equal to 1 minus 1, 1, minus 8, 7, minus 5, 5, minus 4, and 3. Perfect? Okay. So, for this section, it's over. Now, the next section is going to be the multiplication of matrix practice problem. So, there will be some practice problem. There, I will demonstrate the process of solving some problems of matrix multiplication. Okay. The only thing is that you need to follow the processes. I don't ask all one to find or to demonstrate the mistakes in calculation. Just learn the process and practice more so that you can increase your accuracy. Fine. Okay. Now, for the matrix multiplication, let's say we are having some properties which is I into A is equal to A, where I is the identity matrix, right? Now, these things I have discussed earlier also. Okay, cool. And also O, which means the null matrix. All the elements are 0 here. Now, so suppose we are having two variables x and y, right? Now, if you are having two variables x and y, then you can say that either x is equal to 0 or y is equal to 0, or x, y both is equal to 0. But in matrix, if A into B is equal to null matrix or 0 matrix, you cannot say that A is equal to 0 or a B is equal to 0 or both is equal to 0. It is not necessary that any of A and B is 0. So this is something which the linear algebra differs from the normal algebra. Fine. Okay. Remember this stuff. This is one of the most important topic that, sorry, not topic, this is the most important point you should remember. Let's say we are having a matrix A as 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. And we are having a matrix B 3, 6, 2, 1, 3, 4 and say 5, 2, 3. Perfect. Okay. Now what we will do is multiply between A and B. Fine. Now if you are multiplying between 3 and 3 and 3 and 3, because the order of A is 3 and 3 and order of B is 3 into 3, so we need to match the column of A and the column of B. So this rule we have discussed in the previous video, so kindly go through the last of the video and click on the I button over there so that you can reach to our previous video, right? So you should know this rule that column of the first matrix should be equal to the row of the second matrix. So the resultant matrix will be having the order of 3 by 3. Okay. Now these are the matrices. We get it by rewriting them. Okay. Now let's solve it. You go row wise, which means like this, and then go down, right and down, right, down. Remember this. So going towards the right, which means you have going towards the right, you have 1, 2, 3. Okay, and then you have 3, 1, 5. So 1 will get multiplied to 3, and then 2 will get multiplied to 1. Okay, and then 3 will get multiplied to 5, and you have to add all of them, right? Fine. So this is a process by which you can get actually multiplication process. Okay. So if I write the other elements, we have 6, 6, 6 and 2, 8, 9, 12, 15, 12. And similarly, we are having 24, 15, and here is obviously 12. Fine, perfect. And then on this position, we are having 4 into 2, 8, 5 into 4, 20, and then 6 into 3, that is 18. Fine. Okay. Now the next line, which is the R3. Okay. Now R3 is 7. Remember, we are in the position R3 C1. So obviously 7 into 3 plus 8 into 1 plus 9 into 5, 45. So we are having in the second column, we are having 7 into 6, 42. 8 into 3, 24. 9 into 2, 18. And on the third column, we are having 7 into 2, that is 14. 8 into 4, that is 32. And 9 into 3, that is 27. Okay, so that's the way you form a multiplication. Okay, now that's the process. Remember, that's the process. There can be some fallacy in having the calculation, but you have to remember the process. Remember, if you guys are having any doubts while solving some problems, then each and every one of your age is welcome to us. You can share your problems with us regarding matrix. We are happy to help you in any situation or in any case. If you are facing some problems, kindly drop your comments down, or if it is tough to understand our way of teaching, then also you can just put it down on the comments section. Okay, now let's complete the writing of these added values. Okay, what is 21, 8, 25? So we have 21, 8 and 25, so we have 29, so we have 60 and 74, yeah, perfect. And here you have 24 and 18, so 42 plus 18 will gives you 60, and 60 plus 24 will give you 84. And here you have 14 plus 27, okay, then all the 46 plus 27, you have 73, perfect. So this is actually the result of A into B when you get. Okay, now let's solve another problem where we will multiply a matrix, a random matrix A, with a matrix I, which is the identity matrix, to show if we'll get again the same matrix, that is that is A or not, right? Let's say we have A matrix 1 2 3 4 5 6 7 8 9, and we have I matrix 1 0 0 and 0 1 0 0 0 1. Remember this, I have written in the small corner I into 3. This is not written like this. Actually, I have written for you convenience that this is I matrix and this is of order 3. This is not written like this, remember. Okay, so what I am having is 1 into 1 plus 2 into 0 plus 3 into 0. Eventually we are having 1, obviously. And after having the row 1 and column 2, we should have 1 into 0 1, and you are having 2 into 1 as 2, and then 3 into 0 as 0. So what you are having is actually 2. Perfect. I think that's you can understand now the process of multiplication. Let's so we are writing it. Let's say 2, and we have 3. Similarly, we have 4 5 6 7 8 and 9. Okay, so actually this is the matrix you have multiplied with, okay, with the I matrix. So obviously the A into I is equal to, we are getting A. Similarly, if you do the I into A, that will also give you A. Now in this position, the commutative, we know that the matrix relation don't actually follows the commutative law of algebra, but in this case this stuff is violated, remember. Okay, so that's why this is a very special case. Okay, so after this I end my video of this session. We are actually having two sections combined together here. So I hope you guys enjoyed it, and so thank you. If you like our video, please comment down and subscribe must, or after subscribing you must tap on the notification bell, because I have seen many viewers have not even tapped on the notification bell. Okay, so bye, see you, and share our video to the needful. Bye, see you, and okay, see you on the next video. Perfect.